Well, welcome, ladies and gentlemen, to our Spring 2009 Lunchtime Lecture Series. It's very nice to see so many people here for the first lecture. And I hope you've looked at our website or possibly at a printed flyer to see some of the other lectures that are coming up in the series and book in early for them because they do get very popular. My name's Felicity Henderson. I organise the lectures here. So if you have any questions, do come and ask me about them later on. One item that I should mention is that we're recording the lectures for a podcast, which is available on our website in a couple of weeks' time. So do please turn your mobile phones off because they interfere with the recording system. So it would be great if you could do that. And I'd like to introduce to you our first speaker, Michael Lemonick. Michael has come all the way from the States to talk to us today, so we're very grateful to him. He spent more than 20 years as a science writer for Time magazine, writing more than 50 cover stories on science and medicine. And he's also contributed to several other important science journals, magazines, such as Scientific American, New Scientist, Discover, National Geographic, and People. He's also written 4 books on astronomy, and he's come to talk to us today about his most recent book, which is the Georgian Star, we have a copy here in the library. And the Georgian Star, as you know, is about the lives of William and Caroline Herschel. Michael teaches journalism at Princeton University when he's not writing books. So I'd like you to welcome Michael, and we look forward to hearing him. Thank you.
Thanks very much. I think I may have broken it. But I would like to start by reading just briefly from the book itself, and I promise I won't go on too long. But here is where I begin. One evening in the spring of 1781, Mr. William Herschel of Bath, England, presented a report to the gentlemen of that city's literary and philosophical society. Mr. Herschel had joined the society as a charter member about a year and a half earlier. From the start, he churned out scientific papers at a prolific rate on eclectic topics ranging from the purely speculative and philosophical to the concrete and practical. His first report, for example, concerned the growth of corallines, a form of algae that accumulates on coral reefs and rocks along the seashore. Among those that followed were papers titled On the Existence of Space, the question whether a knowledge of the classic authors in their own languages is essentially necessary to one who would write English with elegance and perspicuity considered, and Experiments on Prince Rupert's Glass Drops. The paper he presented in March of 1781 was his 31st. It was also his last. Like many of the preceding papers, this was a report on his observations of the night sky. The title was Account of a Comet. And while Herschel thought it worthy enough, he didn't consider it particularly exciting. On Tuesday, the 13th of March, he wrote, between 10 and 11 in the evening, while I was examining the small stars in the neighborhood of H. Geminorum, I perceived one that appeared visibly larger than the rest. Being struck with its uncommon magnitude, I compared it to H. Geminorum and the small star in the quartile between Auriga and Gemini, and finding it so much larger than either of them, suspected it to be a comet. A couple of years ago, an editor came to me with a proposition that I write a book. He had a series called Great Discoveries, and the books were all scientific biographies of people who had made great discoveries. And so Albert Einstein was one of them, and Madame Curie, and other names you'd recognize, and some you wouldn't. And he asked if I'd be willing to write a book about William Herschel. And the reason he came to me was that, as you've heard, I write for Time magazine, and while I have written about every topic conceivable in science, topics like this, and this, and that are my favorites. I love writing about astronomy. And I think I know something about astronomy. And so with my great knowledge, I said to him, William Herschel, he discovered a planet. So what? It was very nice, but that will take me through about 5 pages of the book. What would the rest be about? And he was a very kind man. So he said, well, why don't you go out and do a little bit of research and see if maybe he's more interesting than you thought. And I went out and I did some research, and sure enough, well, you see there's a book here, so clearly I found, and it's more than 10 pages long. So I did find out a little bit. I found out, among other things, that Herschel's discovery of the planet Uranus was indeed, in a sense, not a big deal. I found out that he did things in astronomy that are mostly forgotten now by all but a few astronomers, but which turned out to be much more important than the discovery of the planet. The discovery made him famous and enabled him to give up his day job, about which I'll tell you in a minute, but he didn't think it was that big a deal in the scheme of things, and it actually wasn't. Another thing I found out about him was that he didn't begin to do astronomy until he was well along in life, probably into his 30s. And I should acknowledge that there are almost certainly people out here who know all of this already. So it's a little embarrassing to admit that I knew so little, but it was a great deal of fun learning about Herschel. So he didn't start, there's another picture of him. He didn't start doing astronomy, as I say, until sort of the middle of his life. And for the first 30 years or so, after he grew to be a teenager, he was a musician. He was born in Hanover in Germany, and his father was a leader of a military band. And in those days, a military musician did not simply show up in the park on a Sunday to play lovely music or greet the king or the prime minister or the president on arrival at the airport or the dock, or play at funerals. A military band marched into battle and shared the dangers and the privations of the soldiers. So William, at the age of 14, enlisted in this band, his father having taught him to play the oboe, and he marched into war. They were fighting against the French at the time, and he tramped through muddy fields and slept in damp tents and dodged bullets on the battlefield. Not a very pleasant life, and he always dreamed of doing something more. Fortunately, his father, who had probably risen as high as he could in life by being a band leader, he had been born in a reasonably low social class, had taught his children, or rather his sons, not only to be musicians, but also about mathematics and astronomy. And he was entirely self-taught himself, Isaac was, the father, in music and in these other intellectual pursuits, but he thought it was very important that a well-rounded man should know these things. Again, the sons learned these, the daughters did not, and that'll come in a bit later. So William had been taught about the stars and had gone out with his father to look at the sky. He had been taught about mathematics and languages, and when he was about 17, 18 years old, the French won a decisive battle against Hanover, and the army was thoroughly defeated. And his father said to him, you know, you've never formally enlisted in the army, so if you disappear, nobody will actually notice. And so, along with his brother Jacob, who got a discharge, they came, I guess I should say, to London. They'd been there once before as a part of a regiment stationed here to defend against invasion by the French that everyone thought was coming. It never came, so William and Jacob instead got to enjoy the life of London in the mid-1700s, and especially the music. This was just a remarkable center of music in those days, and these two young musicians were just in awe of what they heard and what they saw. And so when they left the army, they decided to come back to London and make their livings as musicians. William particularly wanted to be a composer. He found out that composers in London in those days were on every street corner trying to sell their compositions. And so while he did compose a number of symphonies and other pieces, He wasn't able to get them published or sold. He made a living for a little while copying other people's music manuscripts. But he eventually decided that London was just too crowded with musicians. He went to the north of England, to Newcastle and that area, and he took up a life playing in orchestras, teaching music to the children of the rich, and settling in. He would ride between these country houses to give these music lessons, and often ride at night, and he would see the stars, because there were no lights, of course, in those days, no lights between houses and cities, and he began to wonder again about the things that he'd learned about as a child, and he began to do more than wonder. He bought a book with the title Harmonics, which talked about the mathematics of harmony, of musical harmony, but also of the mathematics governing the motions of the stars. He learned calculus, and he was an extraordinary enough intellect that he was able to do this, again, all on his own, without any kind of training. So he would ride back and forth between these houses and teach his lessons and look up at the stars and make notes about observations he made of the position of Venus or the appearance of the constellations, for example. And yet this was still just a kind of a vague interest. His real work was music. One day he heard that a new organ was being built for a church in Halifax, and there would be a competition for the organist. So along with several other eager young organists, he showed up one day. This was something like the American Idol of the 1700s. There was going to be a competition, and whoever played the best would get the job. And the guy who went up before Herschel was very, very good. He was dexterous, he was fast, he played complicated melodies and counter melodies, and he dazzled everybody who was listening. And when Herschel himself got up to take his turn, people basically told him, you know, you shouldn't even bother because you've lost. But Herschel, turns out, was not only intellectually curious, he was creative, and he was, in fact, you might say, devious. Because when he got up to the keyboard, I should tell you that in those days, organs did not have foot pedals. And so the extra bass notes that a modern organist can play with his or her feet weren't available. So you just had 10 fingers. And realizing this, Herschel had a little trick up his sleeve, or rather in his pocket. When he got to the keyboard, he removed from his pocket several lead weights that he'd carried up with him, and he placed them on some of the bass keys and then began to play. And as a result, his tone was incomparably richer than that of any of the other players. People were amazed at the beautiful sounds he could get from this organ. The organ builder was in the back of the room and just was ecstatic, and Herschel got the job. So he got it by cheating, and again, that shows a bit of his creativity and his cleverness. He lasted 1 month on the job, not because they found him out, but because he found out about a better position in the town of Bath. At the time, this was the, as I'm sure many of you know, it was the most fashionable town in the country. Everyone left London in the summer, all the aristocrats and members of the court, and went to Bath to take the waters and to dance the night away in balls and go to concerts and generally be seen by each other. And to be the organist in a church in Bath, which was the position he heard about, was to put him right near the pinnacle of society, or at least in contact with those people. So he went down to Bath, got the job there, and began building a musical empire. He ended up running orchestras and directing choirs and giving lessons and performing as a soloist. While he was in Bath, he brought his young sister, Caroline, over from Hanover. The father had died, and she was now being employed by their mother as pretty much of a domestic servant. She was treated very badly. She wasn't allowed to go out, and she might have escaped this fate by getting married, as her older sister had done. Unfortunately, her father had rightly told her before he died, he said, "Caroline, because you are neither handsome nor rich, your prospects for marriage are virtually zero. Unless at some point much later in life, an old man takes pity on you and marries you for your good qualities of character. So she didn't have much going for her. Here's a picture of Caroline later in life. It's the only portrait we have of her. So, so she was probably, well, she was probably a little bit more attractive than that at the age of 15, 17 when she came over. William had to convince his mother and his brothers that she should come, and to do so he told them he was going to train her to be a singer. He heard she had a good voice. He hadn't seen her in many years. He was going to train her to be a singer. And he brought her over, and that is exactly what he did. He gave her music lessons. He also, because he was his father's son, gave her lessons in arithmetic and other forms of mathematics. And he was determined that his sister be as educated and as versatile as she could possibly be. He was evidently successful in teaching her to sing. This is a flyer from one of the concerts that they participated in. As you can see, it says Mr. Herschel's benefit concert, the Sacred Oratorio Messiah, the vocal parts by Miss Herschel, Caroline, and several other people, and Mr. Herschel. And in fact, she became such a talented singer that she was approached by people from Birmingham to come and take a position there as a professional soloist. He trained her that well. And she declined. She wanted to stay with her brother. And she did for the rest of his life. At this time, William Herschel's interest in the skies began to bubble up again. He was the sort of guy who, when he's got everything going really well, he needs to find some new challenge. And so the music was going beautifully. He was performing. He was making a good deal of money. He was hobnobbing with the rich and famous, and he was not satisfied. He kept thinking about the skies and the stars that he'd seen riding between houses, and he wanted to know more. And he wanted specifically to look through one of these marvelous devices called the telescope that he knew about, with which he could see in much more detail what was going on up there. He just had a yearning to understand the heavens and to understand them in a profound way. So he rented a telescope and was dissatisfied with it. It just wasn't good enough. And he couldn't really afford to buy a good one for himself, so he set out to start making his own telescope. He had his younger brother Alexander, who by now was also living in Bath. And Alexander was not only a musician, like all the Herschel boys, but he was a craftsman. He was a clockmaker, for example, and a furniture maker. And so together they set about learning how to make a telescope. And they did pretty well. This is one of the telescopes that they made. It's now in the collection of the Adler Planetarium in Chicago, in the US. There's one on display at Cambridge University here. And last night at Newcastle, they brought out a big parcel wrapped in newspaper and unwrapped it, and it was the wooden tube from yet another of Herschel's telescopes. It didn't have any of the optics in it or the mount, but it was a barrel that looked just like this. And unlike the ones in the museums, I was able to touch it, so that was kind of fun. So they made these telescopes, and Herschel began thinking about what was going on in the skies. And unlike most of the astronomers of his day, he was interested in understanding the structure of the universe and the evolution of the universe and how big it was and what it was made of. Most of the astronomers at that time were concerned only with measuring the positions of the stars and the planets for use in navigation at sea. It was very important, obviously, to know exactly where the star Arcturus should be at a certain time on a certain day, so you could judge where you were in the ocean. That's, to my surprise, I learned that that's why the Royal Greenwich Observatory was set up, to do that kind of positional astronomy. The other reason people did astronomy was to test the theories of Newton and to calculate the orbits of heavenly objects. Comets, for that reason, were especially interesting because The planets were there all the time. You could just watch them and carefully measure them. But the comets streaked in from somewhere and streaked out again, and calculating their orbits and predicting their paths was a very exciting thing. That's how Edmund Halley became famous. He calculated, or he deduced, that a comet that had appeared in a number of different years over the past 500 or so was actually the same comet that kept returning. He predicted that it would return again in 76 years from its last appearance, and he turned out to be right, and it has been faithful about doing so ever since. It was back in 1986. I don't know if any of you saw it at that time, but it was actually kind of disappointing. But still, it showed up, and that's what's important. So that's what astronomers did, but Herschel didn't talk to astronomers. He didn't know any astronomers. He was self-taught. He was isolated. He made these telescopes. He had no idea whether they were particularly good or particularly bad, but he wanted to understand the structure of the universe and many, many other things. So one night he was out in front of his house in Bath with one of these telescopes, one just like this, and he was looking at the moon. He was trying to measure the height of the mountains on the moon by measuring their shadows and doing a little trigonometry and calculating the heights. And a gentleman happened by and asked if he could take a look. So Herschel let him, and the gentleman was very satisfied and thanked him, and went away. And the next day he came back, and it turns out and he introduced himself. His name was William Watson. He was a fellow of this society, and he was very well connected to the astronomers of the day. And he saw a talented astronomer and a good telescope or he knew one when he saw one. And he asked Mr. Herschel to join this philosophical and literary society. And that's how Herschel got connected. One of the ways that William Herschel was going to attempt to understand the universe and measure the universe was that he wanted to measure the distance to the stars. This was something nobody had yet done. Everyone knew they were much farther away than the planets, but nobody knew how far. And this was very important to him, to gauge the size of the universe. So he used a technique that was already well known at the time. He used something called parallax to try and make this measurement. And how many people here do not know what parallax is? Okay, well, so I think we all have to do an audience participation exercise. All right, I will ask you to take one finger and hold it up at about arm's length, pretty much right in front of you. Take another finger and hold it up much closer, near your nose, and close one eye. And then open that eye and close the other one. And alternate between the two eyes, looking only through one at a time. And you should see that the nearby finger jumps back and forth, while the one in back doesn't. That is because your eyes are looking at the nearby finger through two sharply different angles, and at the more distant finger through not such a sharply different angle. And that difference in angle makes the nearby finger seem to move. It would be the same thing with the stars. If you could find two stars in the sky, one of which was far away and one of it which was relatively nearby, but they were lined up pretty close to each other, and you looked at them through the telescope, say on January 1st, then you looked at them again on June 1st. By that time, the sun would have moved, the Earth would have moved halfway around the sun. It would be 186 million miles away from where it started. So you would be looking at these stars from very different angles, and the nearby star should appear to move back and forth. And because nobody knew where double stars were located, the ones he wanted look like single stars to the naked eye. You have to use a telescope to see them, because to make the most precise measurements, you want them as close together as possible to start with. So he began a survey of the night sky, an exhaustive survey in which he pointed his telescope successively at every adjacent patch of sky and covered in a systematic way the entire thing. Nobody had ever done anything like this before. Again, most astronomers were interested in individual objects and their behavior. Herschel was interested in finding a whole class of objects, knowing how many there were, and using them to understand the universe. And in that, he was extraordinarily modern. This is something that astronomers do even to this day, and most of what we know about the cosmos is not from looking at individual galaxies or clouds of gas or whatever's out there, but by looking at large numbers of objects, whole categories of objects, and seeing how they exist in relation to each other and where their locations are and how they perhaps evolve from one kind into another kind. So he was doing something very new. And it was during one of these explorations, on that night in March in 1781, that he happened on this object. And as it said in the account, it clearly was not a star because it was too big. It had a visible size, and stars don't, even through a telescope. And so the only other thing he could imagine that it was a comet. That's because there were 5 planets known in the solar system: Mercury, Venus, Mars, Jupiter, and Saturn. They had been known since antiquity, and even before they even had names. So nobody was expecting now suddenly to find a new planet, so it must therefore be a comet. It didn't look like a comet because it didn't have the fuzzy appearance a comet has due to the gases evaporating from its surface. It didn't have a tail, but there were no other choices, so he declared that he had found a comet. The other astronomers whom he was now in touch with heard about this. He sent a note to the Royal Society, and it was announced here and across Europe, and others began to look at this thing. And they began to watch it night after night to see how it moved and calculating its orbit, and they pretty quickly realized that this was no comet. They realized, in fact, that Herschel had indeed discovered a planet, the first planet ever found by an individual human. And as a result, he became world famous. Or that is, this is when the world consisted of Europe and England, and that was about it. But that famous among all great astronomers of the day, and they welcomed him as a fellow, and they did not hold his humble origin against him, and they considered him a colleague. And they immediately realized that this provided an opportunity to get Herschel away from the drudgery of his day-to-day musical activities. They knew that if Herschel did the king some great honor in respect to this discovery, the king would be obliged to do something in return. And they went back and forth and kind of negotiated behind the scenes so that it would all go smoothly when it was finally publicly announced. And finally, it was. Herschel did the king the great honor of naming the planet after him. He named the planet George. And so this was Herschel's gesture to the king. The king, in return, gave Herschel a salary of 200 pounds a year and gave him permission to build and sell his telescopes under the royal emblem by appointment to His Majesty, telescope maker to the king. Herschel would also have to move close to Windsor Castle so that the king's guests could come over and look through the telescope whenever they felt like it and see the wonders of the heavens. And this was great. Herschel took a big cut in salary. He was making quite a deal of money as a musician, but this gave him the freedom to do what he really now truly wanted to do. So he moved. He built himself a bigger telescope, because a bigger telescope, which has a bigger light-gathering mirror, the first one had a mirror about 6 inches across. This one had a mirror about 18 inches across. And the bigger the mirror that you're using to concentrate light, the more faint starlight you can get into your telescope. And astronomers to this day are always in search of more light. The biggest telescopes now on the planet have mirrors that are 8 or 10 meters across. And that's not enough. They're not satisfied. So there are people in Europe and the US who are talking about telescopes of 30 meters or even 50 meters across. And they actually have ways of building them. But so he was modern in that sense too. He was never satisfied with his instruments. But he began these systematic sweeps of the heavens, first looking for double stars, but then other things caught his interest. So, for example, he began noticing nebulae. Nebulae are clouds of some kind of glowing material that you see through a telescope. The comet hunter Messier had discovered more than 100 on his own. He was not interested in these objects. He was interested ruling them out because he was looking for comets. So he cataloged these nebulae so that he wouldn't mistake them for comets, the thing he was really after. But Herschel, who ultimately would find 3,000 to Messier's 100, was fascinated with the nebulae themselves. What were they? They were different in appearance. Some were very round, and some were very elongated or even amorphous. And he just yearned to know what these things were. And the way to do that was just to make as many observations as possible and begin to try and think about using the laws of gravity that he knew about, what these objects were. This is an illustration of what a modern astronomer does in the same way that Herschel did. This is a plot, not a photograph, but a plot of the locations in the sky of about 1 million galaxies seen by the Sloan Digital Sky Survey. And what you see in this plot is that the galaxies are arranged into these strange structures where there are voids where there are very few galaxies, and then there are these dense clots of galaxies and wisps of galaxies, hundreds and millions of galaxies connecting them in fibers and structures. So the universe looks a little bit like Swiss cheese. Nobody had suspected this at all before the mid-1980s, when people doing big surveys of galaxies, Herschel-type surveys, found this out to their surprise. And then they started doing more and more, and this turns out to be the basic structure of the universe at the largest scales, and it tells us an enormous amount about what the universe is made of and how it has evolved since the Big Bang. So doing a Herschel-like sweep of the skies has told us brand new things about the cosmos. This is just one of the photographs from which that plot was taken. And most of the objects in this are not stars, but are individual galaxies. This is something Herschel would have just gone crazy over. He would have loved to see this. So he's out looking at nebulae, and he's also thinking about the Milky Way. By this time, people realized that it was that we were inside the Milky Way, that it was a structure that we inhabited. Some thought it was the entire universe. Some thought maybe it wasn't. But Herschel took the daring step of trying to guess what the Milky Way would look like from the outside. What was the overall structure of it? Again, a very modern idea. And he did so by counting the number of stars in all directions and trying to estimate, any place where there were more stars, maybe the thing went further. And he did all these lines of sight, and finally he came up with this diagram of the Milky Way. The dot right in the center here is us. And as you can see, it doesn't here. This is a picture of a spiral galaxy like the Milky Way. It doesn't look exactly the same. But it's actually quite sophisticated in that he figured out that it was narrow in one direction and very long in another direction. And he thought, you see this gap here that looks like an open mouth. It turns out that there are big clouds of gas that hide the core of the Milky Way from our eyes. So the center is really here, and the whole thing goes about as far in the other direction. But given the limitations he was working under, he did a remarkable job. He also figured out what direction the sun is moving through the galaxy. That is, all the stars are kind of moving independently in generally the same direction, but some move faster than others and go across and so on. And he actually calculated where we were heading in the galaxy, and it turns out he was exactly right. Back to the nebulae, these are drawings that he made of what he saw through the telescope. And he tried to classify these almost as a biologist would classify butterflies, noting similarities and differences. And he tried, as I said, to understand how these things were related to each other. Early on, he thought that all of these nebulae were collections of stars. They were just so far away that they merged into one shiny blob. Later on in his career, he decided that they were actually glowing clouds of gas, and they were much closer. They didn't have stars in them. But in either case, he tried to connect the dots, as it were, by imagining how one type of nebula would evolve under gravity into another type. So on the bottom, you see relatively compact ones. Maybe they were a later stage, he thought, where the gravity had pulled them all together. And the one on the top maybe was a very early stage when the material was very loose. Or maybe another way of doing it, he thought, was that if you had two nebulae nearby, they could sort of merge under their own gravity, creating these amorphous shapes. Again, a very modern attempt to apply theory to his observations and come up with an idea of what's actually going on out there. This is a modern picture of a nebula. I should say that you could either say that he was right both times or wrong both times, because it turns out that some of them are collections of stars far beyond the Milky Way. They're galaxies in their own right, and others are glowing clouds of gas, like this one, taken through a modern telescope. He, again, would have just died to see a picture like this. But he needed more light because he needed to know more about the universe. So Herschel wanted to build a telescope that was 40 feet long with a mirror 4 feet across. And he went to the king because even though he was making a pretty good living by selling his telescopes, this was just beyond him. So he went to the king for more money. And by now the king was a bit sick of Herschel and his request for money, but Herschel was a great salesman. So he said, Your Majesty, I offer you two choices. One of the choices was not, do not give me the money. The choices were, I can build you a very good 30-foot telescope, or if you give me a little bit more, I can build you a truly magnificent 40-foot telescope. And the king, thinking, well, I'm a magnificent king, I must have my magnificent telescope. He gave him permission to go ahead. Halfway through, Herschel ran out of money. He came back to the king again and said, I need some more. And by now the king was quite fed up. But Herschel said, Your Majesty, I understand how you feel, but think about it. You've already spent 2,000 pounds building half a telescope. Do you want that money just to be thrown away, or do you want to give me the money to finish it? And the king said, fine, okay, don't bother me ever again. This is the last money you're getting from me. And Herschel said, well, one more thing. And I paraphrase, something like this. My sister Caroline, who has been my assistant all along, is so skilled and so necessary to my operation of the telescopes and of my work that I either have to hire a new assistant, and that'll cost money, or you can let me hire her. And so I'd like you to give Caroline a salary as well. And so the king awarded Caroline Herschel 50 pounds a year as the assistant astronomer, and as far as I know, never gave Herschel a penny again. But with that stroke, Caroline Herschel, who had been started out as a servant in her mother's house, then almost became a professional singer and only turned it down because of loyalty to her brother, was now the first professional woman astronomer in history. And that is how she's remembered. That's one reason she's remembered. Another is that when William went off to sell some of his telescopes to other kings and queens in Europe, he couldn't let the observing program lapse, so Caroline just kept on by herself. And so she kept sweeping the night skies, looking for the kinds of objects he was interested in, and cataloging nebulae. And one night she came across a comet, and she thought it was a new one. She hadn't seen it referred to before, and sure enough, it was a brand new comet. And so she became the first woman ever to discover a comet. And she went ahead to discover 7 more, which made her an object of enormous celebrity in England. She was, surprisingly, treated just as well as her brother by the gentleman who did astronomy in those days. She was treated as a serious observer and a serious scientist. And at one point, she was evidently up for a medal from the French Academy of Sciences, which itself is kind of surprising because nearly 100 years later, they refused to let Marie Curie join the French Academy because she was a woman, and we don't allow women. Nevertheless, she was in the running. Caroline was in the running for this gold medal, and she only lost it because William was also in the running, and he had done a bit more than she had. Nevertheless, this established her as a serious astronomer, and she was treated that way for the rest of her life. Okay, one more thing about William. As I said, the discovery of Uranus was, and maybe now you can see that it was kind of a minor thing in the in the great scheme of his life. He invented a new way of doing astronomy, and it's one that is still in force. The catalogs he made of the sky that were compiled, he did the observations, Caroline compiled them, and his son, John Herschel, who inherited his work, extended them to the southern hemisphere, and they became the basis for the star charts and galaxy finding charts that professional astronomers used well into the 1950s and 60s. So he was a fundamentally important theorist and observer and telescope builder, because his telescopes were some of the finest of the day, completely untaught. Oh, actually, I had to tell you one more story about the king and this thing. Herschel realized that it was not good form to let the king know that this telescope never actually worked very well. The mirror was beyond his capabilities. It was too big. It was too hard to polish. It just was not a good instrument. But what he would do on more than one occasion was he made some other discoveries in the solar system, including the first moons of Uranus, several new moons of Saturn, some asteroids. He would actually find these things on the 20-foot telescope. Then he would run over to the 40-foot and look and say, oh, yeah, okay, I think I see it, and announce to the world that he had discovered a great new thing with his 40-foot telescope. So the king thought he had his money's worth. Herschel was also interested in the sun and the planets. He particularly thought that the sun was just another planet, although a lot bigger than the others, and that, like all the planets, he believed, the sun was inhabited. There's a kind of an obvious question that comes up right away, which is, why have they not burned up long ago? And his answer, which was the answer that agreed on by some other people at the time, was that the shiny surface of the sun that we see is actually the top layer of luminous clouds that completely encircle the sun, very brightly shining clouds. But the bottom layer doesn't shine at all. It actually protects the sun people from the burning rays of the sun. And so they stroll around quite happily, doing whatever they do down there. And of course, we can't see them, except that the sunspots that periodically march across the sun are, in fact, holes in this cloud layer. So if we could somehow block out the glare and look down, we might actually be able to observe the sun people. In order to look at the sun at all and see the sunspots, he had to look through filters, because he would destroy his eyes by looking straight at it. So he would make filters out of glass vials filled with colored liquid. He would put different colors of ink into the water and make a filter that way. And he noticed that some colors of filter seemed to let more heat through than others. So that got him wondering. Everyone knew that sunlight was made up of different colors of light. And if you put light through a prism or you look at a rainbow, you're seeing those colors separated out. So he wondered, which colors were the most effective heat transmitters, which colors of light. And so he set up this prism, and he took out some thermometers, and he would move the thermometers into the paths of different colored light. So he went from the violet on one end, and then through the yellow and the green, measuring how much the temperature rose in each case. And then he had I don't know how to describe it, a moment of inspiration or just curiosity. And he took the thermometer and moved it beyond where there was any light, just beyond the red. And to his astonishment, the temperature went up even higher. So clearly, there was some kind of light coming from the sun that was invisible to our eyes, but which carried heat with it. He called this form of light calorific rays. We now know it as infrared radiation. And it has turned out to be extraordinarily useful and important in all sorts of ways. The remote that you use for your television uses infrared light, but that was not what I mean by important. It also turns out that many astronomical objects shine very brightly in infrared light and not very much at all in visible light. So if you can look through a telescope with infrared vision, by using a film or a light detector that's sensitive to infrared, you can discover all sorts of things about the object that you couldn't otherwise know. This is the curve, the two curves he had drawn. The one on the right is the curve of visible light, and the one on the left is the curve of where the heat is greatest. And you can see that the peak of greatest heat is beyond where visible light even exists. This is a picture of a nebula, another of Herschel's nebulae. but taken through a modern space telescope equipped to see in infrared light. And this object looks entirely different, almost looks like nothing in regular light. In infrared, you can see all this marvelous structure of these swirling clouds of gas and dust. And so, with this discovery, if this was all he had done, it would have been more important than the discovery of Uranus. And of course, it wasn't all that he did. This is an image of an artist's rendering of the James Webb Space Telescope. It's the successor to the Hubble telescope. It's going to be launched in about 2013. And it is going to see almost entirely in the infrared, because it turns out that two of the most important phenomena in the cosmos, the birth of the universe, the birth of the galaxies, and the creation of new planets around other stars, are most easily seen in infrared light. So this is going to do what Herschel yearned to do, extend our vision to the very edge of the universe and learn a great deal more than we've ever known about where it came from and what it's made of, and also about his other passion for looking at planets and imagining the people that live there. By rights, it should have been called the William Herschel Telescope. Then, if it had been, then I wouldn't have been so surprised when I was asked to write a book about this guy. But instead, it was named after a bureaucrat who ran NASA in the 1970s. So his children are happy, but astronomers maybe not so much. This is the actual William Herschel Telescope in the Canary Islands. It's a good telescope. This mirror is about 4 meters across. So it's nothing like the biggest ones on Earth, and soon it will go in even one more category down when these giant new telescopes are built. It's sort of unfortunate that this is all Herschel gets. He's had a crater on one of the moons of Saturn named after him, and I believe there's a new satellite being launched in a few weeks, also named after him, and I think its object is to look for planets around other stars. Nevertheless, the most powerful and exotic telescope ever built by human hands, I would say, rightly belongs to him. And with that, I will stop and ask if anyone has any questions.